All right, well, thank you for all coming out tonight. And good to see some familiar faces. I'll tell a little bit about myself before we get started, and then as we go through, feel free to ask me questions about some of the photographs. So I grew up in the Apollo era, so anybody my age kind of got the bug for astronomy at an early age when you got to see those Apollo missions landing on the moon. Came from Cincinnati, Dayton, Ohio area. Moved out to Colorado in '94, started teaching at Berthoud High School in 1995. A wonderful school. Taught for 28 years there. I taught physics, chemistry, night astronomy. Great memories of teaching the night astronomy class out here in the observatory. Now Crystal's taken over the march on that, so it's a wonderful facility for that. Then I went into retirement, and like Mark said, I tried it for 3 weeks and hated it. So, so got the opportunity to work at Resurrection Christian, and I jumped at it and absolutely love it there. And now I'm teaching math of all things at Resurrection Christian. So I'm still in the teaching mode and still doing astrophotography. And I was bit by the astrophotography bug back in college, and I've been addicted to it ever since. So I've kind of been through the whole thing back in the days of film with manual guiding all the way up to the digital era. So on the presentation, I kind of have it broken into 3 levels. The real basic stuff, how you can get started. I'll refer to something like this, basically just a camera on a motorized mount, and you can take wide field pictures like that picture there of the Milky Way. It doesn't take a telescope, it doesn't take a lot of money or fancy equipment. Simply track the stars for 20, 30 minutes, and you can do all kinds of amazing stuff. The middle part is basically taking the camera and inserting it into the back of the telescope. So now the telescope is acting like a telephoto lens. That's a little more technical. It takes a lot of equipment to do that. And then finally, the last part, this is new for my presentation, the AI, artificial intelligence, they call for computer programming, how that has revolutionized the field of astrophotography. And as you know, it's revolutionized many things with ChatGPT and many things like that. So I'll talk about how has it changed the field of astrophotography. And I'll give you some examples of before and after pictures that I took years ago that I thought were bad botched pictures, out of focus, bad images, and ran them through some AI programs and show you what they can do. And it's neat and scary at the same time, anytime you have something new like that. So that's kind of how I'll end the presentation there and then open it up to some questions you may have, okay? So with that said, we'll go ahead and get started here. So first thing is, why astrophotography? So if you've ever looked through a telescope, like I said, when I got my first telescope when I was back in high school, I saw these really cool pictures in the science books. Pictures of galaxies, red nebulas, and I thought, wow, wouldn't that be cool to see that through a telescope? So it was just a little 60mm refractor, something you would see at Walmart. And when I found my first nebula, it was a whole range of emotions. I was excited, thrilled. I found the Orion Nebula, but at the same time I was a little let down because it didn't look like the picture. So it's kind of a mixed emotion thing. But nonetheless, I was bitten by the astronomy bug. And I just thought, okay, if I wanted to see all these bright colors, I just needed a bigger telescope. So college comes along, save up more money, get a bigger telescope, and it's the same thing. It's kind of like this. And it's kind of a gray. You could see the nebula, but the colors weren't there. And that's when I learned if you want to see the vibrant colors in the nebulas and the galaxies, you got to take a picture. And back in the old days, it was film, okay? So you take the camera, stick it on the back of the telescope, and after 30 seconds to a minute of exposure time, then the colors start showing up, and that's when I became hooked into astrophotography, and it's been an addiction ever since, okay? So that's why I do that. So here's a picture of the Orion Nebula I took through the telescope, and you can see the detail and all the reds and stuff. It's a very easy nebula to photograph. Most of the pictures on the presentation I took, except for a few examples of things I needed that I didn't have an image for. So that's why I do astrophotography, to see the colors, to see the detail. And it's kind of a possessive thing. Yeah, that's my own picture, kind of neat thing. So that's the basic general outline, which I talked about already. To get started, I always tell people, you just got to jump in. You just got to try. Cell phones are amazing today. I never thought I would see this 10 years ago. But they're taking pictures of the Milky Way galaxy with cell phones. Now, I don't use a cell phone for astrophotography, but someone else took this picture with a cell phone on a little tripod like that. They have these little things that can hold your cell phone. When I did night astronomy and my students took pictures with their cell phone, I always found out the iPhones and the galaxies seem to be the best. Of course, I got a Motorola, so I wouldn't know, but anyway. The iPhones are amazing when you can take a picture of a galaxy. You just got to get to a dark sky site. June, July, August are usually the best months for doing the Milky Way. But if you can get outside of the city and you can put your cell phone on a little tripod, you can get something maybe not quite like that or similar to that. And each year, each cell phone generation gets better and better with those cameras. So I never thought I would see the day where a cell phone could do something like that. So it's not hard to jump in. You just got to try it. This is what I was kind of referring to over here. Just putting it on a tripod. It's the easiest thing in the world. Now, this wouldn't track, so it's kind of fixed. And because of the Earth's rotation, if you expose too long, the stars will start to get streaks in them. So you got to keep your exposure time kind of short, like 30 seconds. Wide angle lens, but if you take many pictures and stack them together, you can get some pretty good results, and you don't need fancy equipment. That's kind of the first way I got started out, just putting a camera on a tripod. And of course, this is the most important thing you need, a truck and some dogs. So go to a dark sky site, and people always ask me, Scott, what do you do when you got your telescope and your cameras in it? You can't see anything through your telescope. What do you do all night? So that's not my telescope, but I have something similar to that. So I pack up a really big telescope in my truck, and then I'm observing all night while I'm taking pictures. So I'm getting a double dose of what I love to do and taking pictures at the same time. So it kind of helps you occupy your night. If you're taking 6 hours of astrophotography session, you can look at some cool things through a telescope too. So that's how I'll pass a clear night. So this is a simple picture. It's unguided. It's just a camera on a tripod. I was in Wyoming. This is real close to the Wyoming-Colorado border. You can see the Laramie River right there. This is called the Laramie River Overlook. You can see the dirt trail. And the Milky Way is clear as a bell. That light pollution right there is Fort Collins. If you're going to do this, I recommend find a good foreground object. It makes all the difference in the world. It gives you depth perception. Without the foreground object, it's just a bunch of dots and a streak in the sky. You don't really know what it is. But having the right foreground object is what makes a good astrophoto. Okay, so it doesn't take a lot of equipment. It just takes finding the good place to go. And here's another one. Let me talk a minute about this. To me, astronomy and astrophotography speaks to my heart and soul. Oops, sorry, didn't hit that there. So, just getting away and getting out underneath the stars is such a relief. And I got to tell you, when I took this picture, I was under a lot of duress. I had just found out that a former student of mine who had just graduated a few years ago was killed in Afghanistan. His name was Kindt. Had him for 4 years, very close to this student. You got to really know the student. He went to School of Mines for 1 year. He was a bright future as an engineer, but he wanted to serve his country. And he went over to Afghanistan, and he never came back alive. That night when I heard the news, I just drove straight out the Pawnee grasslands and just said, I just got to get under the stars. So that picture means a lot to me. So astronomy, it speaks to the heart, the mind, and the soul. So when you get out under the stars, it's almost a connection you have with them. So that picture has special meaning to me because of what had happened that night. This was taken up at Pinewood Reservoir, just above Carter Lake. So you can see the light pollution there is Loveland. And it's on a tripod, and it was such a perfectly still night. You could see the reflection of the stars on the lake there. So very clear night. It was about this time of year too. It was fall. The trees were changing color. So that's what it was like up there. And this was another cool night. I was at that same place at Laramie River Overlook trying to get some Milky Way shots. And I looked to the north. I'm like, what are those red lights there? Never seen aurora borealis like that before. And there has been a solar flare 2 days ago I didn't know about. And these red pillars were shooting up in the sky. So I turned my Milky Way shot into a panorama so I could catch the aurora borealis there. Totally unexpected, just being at a dark sky site at the right time. But it's unguided, camera on a tripod, pretty simple to do. And there's Venus and the moon. That's a good way to start out, just shooting something like that. When you get up early in the morning, you can see Venus there, reflecting off the stars there. And some people get into storm photography. I happened to be on Pawnee grasslands one night, and it was a clear night. You can see the stars above, and this storm rolled down through the plains. Now, that's taken through the telescope, so I wasn't in the storm or anything. It was a good distance away. But caught some nice lightning there and some stars above it. So kind of being at the right place at the right time. Yeah?
Was that exposure?
Yeah, so you can tell by the track of the stars that it's probably maybe 4 or 5 minutes. It's because it's on a tripod, so it's not moving at all. So I just locked the camera lens open and aimed at the storm and waited for the lightning. So, all those lightning bolts didn't come at one time. It was over that 5-minute period you're capturing each one of those bolts coming down.
Thank you.
And here's my last one of untracked. If you go up Trail Ridge Road in July, you'll see a lot of people pulled off to the side. Okay, they're either listening for elk or whatever, but a lot of them have cameras and tripods. You can get some really good Milky Way shots up on Trail Ridge Road. And like I said, putting a foreground object makes all the difference in the world right there. If you want to, I'm not going to get too much into this. Back in the days of film, people did a lot of star trail photos, but if you ever wanted to do a star trail photo, you find the Big Dipper, Ursa Major, and it points right to the North Star Polaris. Everything's going to circle around Polaris in the next 3 pictures. So it's as if Polaris sits still. I describe it to my students, the night sky is like an umbrella. You open up a black umbrella, and you got the point of it, and you spin the umbrella. The point is the North Star, and everything on the umbrella is doing a circle around it. And the further you are from the point, the more the stars are moving. And because of that, it's really the Earth's rotation, you get this kind of star trail effect. So the North Star is right there, there's Polaris, and as you move further away, the stars are tracking more and more.
How long with that exposure?
So probably about 10 minutes, and that was with film. I took that before digital cameras, so that was up in Wyoming. But yeah, pretty easy to do. You can do it with digital cameras to do, so it probably comes out a little better there. This was in Moab. My wife and I in the back there, we were camping in Moab, Utah. I was waiting for the moon to set so I could take some astrophotos. So I thought, I'll just take a picture of this butte while the moonlight's still out. And the moonlight illuminated the buttes perfectly there. You can see the North Star up there. Yeah, so because you can tell, look how long this exposure is by how much the stars have moved. That's pushing maybe close to an hour. So with that long of exposure, yeah, on film, this is a medium format camera with film. It literally looks like daytime because the moon's illuminating everything. Yeah. Same with this picture here. This is the middle of the night. I'm in a field outside of Boulder, pitch black, but a very long exposure. And look at what you can see, NCAR up on the hill there. It looks like daytime. I mean, there were coyotes running around in the field and everything, heard all kinds of noises, but you can see by the length of the star trails how long that exposure was. So very easy to do, just a camera and a tripod. The next step, let's say you get bit by the astronomy bug like I did, and you say, okay, what do I do next? I recommend buying one of these things here. They're not too expensive, but that's got a little motor in it, and then you can put your camera on there, and what it'll do is it'll rotate to match the Earth's rotation so that the stars stand still. And now you can go much deeper. You can put a telephoto lens on your camera. Mark was showing me some pictures he did with this tracker there. That tracker I have right over there, something like that. They're light, they're portable, not too hard to do. And here's a picture I took of the Milky Way. So you can go much deeper, much longer exposure. And this is Scorpio right here. There's the heart of Scorpio Antares. The tail kind of loops around, and Sagittarius is here. And that's right in the center of the Milky Way. This is under a very dark sky in Utah. The black here is a foreground. There was like a mesa or a butte in front of me that was kind of blocking the stars there. But nothing more than a camera with a tracking mount for a long exposure there. And same with this. Remember Comet Hale-Bopp, 1997. Those of you that were around then, what a spectacular comet.
Move to the side so people can see the real picture behind you.
Oh yeah, there's, yeah, so there's the real picture. It came out a little dark on the picture there. It's much better projected up. This is back in the days of film. So there's a lot of grain in that picture. Oops, didn't mean to do that. That's up in Ridgeway, up in the mountains there, Ouray Ridgeway. And you can see the Andromeda Galaxy right there showed up on the film. And the blue ion tail, which you couldn't see with your eye, but showed up on the film really clear. Okay, fast forward to a few years ago. That's film. Now here's the latest comet, and that's with digital. Different comet, but look at the difference in quality of how a digital camera can catch so much more detail. So Comet Neowise, that's up in Wyoming. Wasn't as bright as Comet Hale-Bopp, but like I said, better camera equipment, and you got the blue ion tail there and the dust tail, and the tree adds a bit of depth to it. So a lot of people photographed that comet. It was a neat one. This is a telephoto lens, not a telescope, on a sky tracker, and it's called the California Nebula. I guess it looks, I don't know, that's a stretch of the imagination there, but anyway, they call it the California Nebula. Now, for my camera, I don't recommend you do this unless you have a dedicated astrophotography camera. You can remove the infrared filter, okay? All warranties are void if you do that, okay? You're not gonna be able to take it back. But when you remove the infrared filter, you can pick up more red in the nebula. This is all hydrogen nebula. And removing the infrared filter allows you to go deeper into the red. It's not too good in daytime anymore unless you do a white balance, because this camera here, when I take pictures of my family, everybody's got a red cast on now. So I use it just for astrophotography. But it allows you to pick up more hydrogen detail. And you can have people do it for you if you feel kind of bad tearing your camera apart and removing that little filter there. Okay, this is my latest image. I took this just last month, actually 2 months ago. I was up in Fox Park, Wyoming, very dark sky, good digital camera. Got the heart of the Milky Way here, and these mountains are in Cusco, Peru. So it's a total fake image, okay? But I took both of them, so at least I'm honest about it, you know? So, but basically, it's a little dangerous to take pictures in Peru, okay? You don't want to be alone at night. So I took this picture in the daytime, and I darkened it a little bit and then combined it with my Milky Way picture so that I sandwiched the two together using some of the AI programs out there. So at the end, when I talk about AI processing and how it can be done, it can blend the two together so seamlessly that you don't need to be an expert with Photoshop anymore. Almost anybody can do it and combine the images together. Because the original image I took just had a few flat trees. I was up in Fox Park, Wyoming. It was a burned out area. Most of the trees were burnt. So the foreground wasn't the best thing in the world. So I tried out in this picture of the Andes in Peru, and it came out really nice there.
How long was the image of the
So,
Milky Way?
so the Milky Way, that's multiple images. Probably I took about 7 or 8 images on that tracker right there, and I stacked them all together so that you can get the detail. You can see there's Scorpio there, but all of the reds, like the Lagoon Nebula and all that stuff, shows up after the long exposure.
Were each exposure a length of time, or was it?
Yeah, each exposure, I think I was 45 seconds there.
And then you stacked that
Yeah,
all together?
exactly.
Okay.
I was about ISO 800 with a 24 millimeter lens, and stacked them all together and ran it through some AI programs to smooth out the background a bit, and that's how it happened.
Nice.
And that was with the Canon 60, so it's a full frame sensor there. Okay, so the middle part of the presentation here is a little more technical. This is basically using your telescope as a telephoto lens. You can use a normal DSLR camera, or this is a special camera called a CCD camera. All it is basically, it's a fancy digital camera with a cooling system, so the temperature gets really cold on the camera, and then sends the signal directly to the computer, so it gets processed right away. Gives you a little bit more depth, more detail in your pictures. But if you have one of these, it works just fine. And I use small refractors, things like this is one of the refractors I use. People always think you need a giant telescope. This blows me away. These small little refractors on a mount with a motor that can track give you amazing detail, wider field of view. So I'm all for using these small refractor telescopes.
Do you know how much does a CCD cost?
Depends on how big the format are. It's a decent one start at about 1,200 to 1,500.
Okay.
So a little more than your typical digital camera, because it's a specialty niche market.
Right.
Not everybody's buying one of these, but and this is one where that just tracks onto a star. That's called your guide telescope. So this one locks onto a star. Your computer tells the motor mount how to move, so it's always tracking for you. And then this is the one taking the image here.
Nice.
Okay, so it kind of works as a system there. And if you're going to do this, you want to find a really dark sky site. So see Denver right here, we're right up here. This has been a problem lately. But you want to shoot for these really, if you're going to really get into this, these are the best areas to go. Moab, Utah, wonderful area. Lake Powell, there's Moab right up there. New Mexico. Up here looks good, but that's bear country. You're up in grizzly bear country. You don't want to be alone at night there. So, okay. And then Nevada's out there. So anyway, but look at out east. So I said I was from Cincinnati, Dayton originally. Never saw the Milky Way out there. All times I was hooked into astronomy. I'd read astronomy magazine. They talk about the Milky Way. I'm like, Milky Way, I don't get it. I don't see it. Never saw it out there. Come to Colorado. I was like, oh, now I know what you mean. It's this huge band in the sky. I'd never seen that in Ohio before. So we were really fortunate. But the light pollution is an issue out here. So usually what I'll do if I'm going to do a one-day trip is right there. The Laramie River overlook is in that dark sky. Right there, that's where I was at. So some pretty good skies there. So this is the next 3 images. This one and the next 2 are my favorite. Yeah.
Not to discourage anybody, I image off of my 4-5 back patio. It's more challenging without a doubt.
Yeah.
You don't have to go down.
Sure. You can take a lot of short exposures that way. Yeah, but also I'm observing too. So got to get the dark skies. So, and in fact, this was in Pinewood Reservoir. So yeah, about the same there. So this is the Horsehead Nebula right there. When you look at Orion, you see the 3 stars of Orion's belt. There's 1, the 2, and the 3 are off the screen there.
Okay.
So you're right by the 3rd lower star of the belt. Now this is the beauty of astrophotography. I've been looking in this area for years, ever since I've had a telescope, and I've never seen the Horsehead Nebula. But when you take a picture of it, it shows up right away. Okay, so this was taken with a CCD camera and a 4-inch refractor. So not a very big telescope, you know, but a high quality lens, long exposure time. And you know, like I said, I was in Pinewood Reservoir, which isn't that dark. It's out of the city, but it's decent.
I
Okay.
thought nebulas were like glowing clouds. Why does it look dark?
So there's different types of nebulas. This is called a dark nebula. Basically, if you can, you almost have to see 3D, like an inverted saddle. Think of an inverted saddle, and this part of the saddle is coming up. So it's blocking your light here. So if you can kind of see the curvature or the fold to it, you can see little ones down here. You know, they're not famous because they're not in the shape of a horse head. But this one happens to fold up, so it blocks your light like a silhouette. And that's why you get that effect there. It's just a random effect of the way it folds up there. And this is the Andromeda Galaxy right there. Now this was at a dark sky site. I was at, it's called Dead Man Mountain, just west of Red Feather Lakes, about 10,000 feet. Really crystal clear September night. You know how you get that fall weather? And that was actually taken with film. So with a astrophysics refractor, similar to the one they have up in the dome, and some film, many exposures stacked together. But you can see the little satellite galaxy here and here. So think of this as a different version of our Milky Way, a bit bigger than our Milky Way. If this were the Milky Way, our solar system would be about halfway out from the center. The Milky Way has more well-defined arms, but it's still a galaxy, okay? It's part of our cluster there.
So do you set the lens of the telescope so that it actually frames that picture like that, or is the frame much bigger and then you use a computer to crop it?
So it depends on your focal length. Because I was using a medium format camera, I was able to get it all in one shot.
Oh.
But I have done this as a mosaic. I've done a 4-frame mosaic. It's a lot of work to do that. But I've also done it with digital cameras and mosaic, you know, all 4 corners together.
But it's not like on the original picture, it was just a little puff in the middle and then you...
Oh, no, because when you do that, then you get all kinds of grain with
Right.
film. So it actually framed in perfectly for the telescope I was using in the camera. It all fit in perfect.
Scott, you got a question back there.
Oh, yeah, sure.
Yeah, sorry. When you're taking your pictures, and you're looking toward and you see the galaxy, are you looking at the center or are you looking at the edge?
Are you talking our Milky Way?
They're arms.
Yeah, so the center is right where Sagittarius is. So it's right on the horizon in July and August, and you're looking at one arm going up. There was an astrophotographer back in the late 80s and 90s, back in the film days. He wanted to get the whole Milky Way. So he took everything he could from California, and then I think he flew to Zimbabwe to get what was below the horizon, stitched it together, and it was like 16 frames into a giant mosaic, and then boom, there's your whole Milky Way. So below the horizon, you have to go south of the equator to see that.
Mr. Sloan, we can show you Sagittarius outside here. Scott.
This is one of my favorites too, because this was by far the hardest picture to take. I tried and tried and tried, but the nebulas are really faint in that picture. It took everything I could. Now this is a 4-frame mosaic.
Okay.
So you're looking at the heart of Scorpio right there. This is called Rho Ophiuchus. It's basically real close to the center of the Milky Way, but you got so much stuff going on here. All of this dark gas here that blocks your view. They used to think that was areas devoid of stars, and then they realized it's actually gas that's not illuminated that's blocking your view behind it. The colors are amazing here too. Those are all natural colors. You don't see blues, yellows, and magentas in one picture very often. So to me, this is like eye candy, the favorite part of the sky for photography. You even got 2 miniature globular clusters. There's M4 and a smaller one there. There's so much stuff going on there from a science perspective, but it's just beautiful to look at. So, but a very faint nebula. It took the best telescope I could afford at the time, and many nights. Like I said, it's 4 frames. You can't tell it because I stitched them together on the computer, but it's such a big area, it wouldn't all fit in one picture. So a lot of work, many nights went in to take that picture, but it was worth it. And there's the Lagoon Nebula, a little bit easier to take that one. That's in Sagittarius that Mark was saying. So when you look at the Milky Way picture, that little pink glow you see in the Milky Way, that's a zoomed in picture of that nebula where stars are forming. And there's the famous Orion Nebula. If you're going to start off with astrophotography, this is what you start off with. Can't miss it. It's easy to find, super bright. Now it gets a little technical because the center is very bright. So what I did is many exposures, some very short and some very long, so that you could combine them all together so that the middle wasn't all washed out. A lot of times when people are starting out, you'll see the middle's all white because they haven't underexposed the middle yet. But when you can combine them together, you can get, it's kind of like with cameras, when you're taking a picture towards the sun, you don't want the sun to wash out your picture. So you'll combine different exposures so that everything comes into view there.
So if you had longer exposure, would you get more vibrant color? Or is that?
That's pretty much it. I mean, you can do things in Photoshop to make it more vibrant. I've seen different, that's where personal tastes come in.
Yeah,
You know?
but I mean, accurate to what you would see optically if you were closer to the actual phenomenon.
Uh-huh.
So that if you left longer exposure, it wouldn't really increase the color.
No. What you would get is, you see this nebula starting to show up here,
Yeah.
you'd catch more of that
I see.
with the longer exposure. When I did this with film, you couldn't see any of that. It didn't show up. But with digital cameras now, all of a sudden that starts showing up there. And the Pleiades, this is rising at about 10 o'clock at night. You can't miss it. Looks like a little miniature dipper,
I
okay?
thought it was supposed to be 12.
Yeah, maybe I don't know, what time is it? Rising around 12, so it's a little dipper there. But all of that gas is there. So I've been seeing this at nighttime all the time. But real easy to see. They call that the Subaru cluster. When you look at the keys of a Subaru, you got the star cluster there. And I took this one through the telescope. So I used to sell up in the galleries in Estes Park and the mountains and stuff. And this picture sold like 5-to-1 ratio compared to everything else. People would come out to Colorado. They wanted a picture of the Twin Peaks and the moon. So I wanted it to be natural. And that is a natural picture because if you look at the moon when it's set, when a full moon sets, sometimes it's to the right of the Twin Peaks, sometimes it's to the left. But this one actually set right in the center there. It was in June, so it was like early morning, 5 o'clock. The sun was just coming up to illuminate the Twin Peaks there, and there were some clouds out. So I wanted that to be a natural picture. So that's kind of the way it came out there.
Where are you standing?
Right here in Berthoud, just by Berthoud Elementary. There was, where one of the roads kind of dead ends there. I had a good friend, Chet Rideout, who used to be at the observatory here. I was just down the road from his house and just set up on the dead end road. And you can ask my wife. There was a time period for like 5 months I was getting up. Every time there was a full moon and the moon was setting, I would get up to take a picture of it, And half the time it's over here or over here. But that time everything just lined up perfect. So a little bit of technical stuff here, not getting too involved here. When you take a picture, it's called RGB, red, green, and blue. So your camera does this automatically. You have filters called the Bayer array. You have red filters, green filters, and blue filters. And your camera combines them together into what's called true color. That's how a normal color vision makes, okay? With photography, you usually take a picture with a red filter, a green filter, and a blue filter. It's called normal true color, okay? Now there's something you can do called narrowband filters. And the beauty with these are, what they do is they're very narrow. They only allow a very slim slice of light through. And the slice of light they let through corresponds to the different elements in the nebula. The biggest one would be this hydrogen, HA it's called. It lets just that light through, which is right on the border of red and infrared. And then the oxygen 3 is where a lot of nebulas shine. So if you have these 3 filters, they usually use hydrogen, oxygen, and sulfur. What it allows you to do is you can take pictures in the city. It blocks out all of the light pollution and allows just the nebula to come through. So now I don't have to travel really far, especially on cold nights. I can take what's called narrowband images. And you'll notice it right away when it's a narrowband image after you see this here, because they all have that greenish cast to it, greenish aqua blue cast. So there's the North American Nebula, and I took that in my backyard. I live in downtown Loveland, right by Bill Reed Middle School, with bright lights shining in my backyard. So tons of light pollution. But with the narrowband filters, boom, you can take this picture here. So you can kind of see the shape of North America, okay, right there, and that's called the Pelican Nebula. And I call that General Grievous. Looks like that from Star Wars there. Here it is side by side. So I took both these pictures. This is red, green, and blue, normal true color. That's the color of the nebula. Hydrogen gas glows red like that. When you put narrowband filters on it, this is a slightly whiter image, that's what you get. Now when you see those pictures by Hubble Space Telescope, like of the pillars of creation, I'll show you in a second, those colors are because Hubble is using narrowband filters, okay? Some people like this image better, some people like the true color. It's personal preference. I think there's a lot more information in the narrowband, especially from a scientific point of view. There's the Rosette Nebula. I took this picture with true color, red, green, and blue. And there's the same nebula with narrowband. And this, of course, was taken in the city, but you wouldn't know it. All the light pollution is blocked out. So you can see the sulfur, hydrogen, and oxygen, the different elements shine in a little bit better. And this is called the Elephant Trunk Nebula. You can see why right there. Same deal. I took this in my backyard. Lots of light pollution, but all that color is in there.
So are these composite images for you?
No, this is,
Individual filters?
well, 3 separate pictures for each filter and then 1 image. Yeah, so it's not a mosaic or anything like that. It's pretty straightforward. Here's the Hubble Space Telescope. So I don't know who took this picture. I just got it off the internet. But that's the Eagle Nebula, called the Pillars of Creation. That's the true color of the nebula. The red is from the hydrogen gas. This is the famous picture that Hubble took called the Pillars of Creation. But now you know how and why it did the picture. It did it with narrowband filters. You can give it, it's a dead giveaway when you see that aqua blue green color. That's not the true color of the nebula. That doesn't mean it's a false image. It just means it's just focused on those elements turned into a picture, okay? And then the last part of the presentation, AI. This is where it's kind of changed me. So when I was retired for a few weeks, I got to really jump into these AI programs, and there's a lot of stuff out there to learn. I tell you what, but it's crazy. For those of you that are into astrophotography, this is kind of a key thing for you here. Some of the ones I use is when I'm doing an earth and sky shot. So if I'm doing the Milky Way combined with the foreground, there's something called Luminar Neo. I really like this program. It's super easy to use. Anybody without a background in photography, you can combine this picture, that picture. They even give you pictures of the Milky Way with the program. So you could even download your own picture from there and add it to whatever you wanted to. Russell Croman is an astrophotographer, and he's down in Texas. He's also a computer programmer. And he's jumped on the bandwagon. He's actually written his own programs, and he sells them to astrophotographers. This one is changing the world of astrophotography. It's called Blur Exterminator, and I'll show you some pictures before and after what Blur Exterminator does. Same with Noise Exterminator. It's specifically for astrophotography. It smooths out the background, makes it a little bit clearer. And then some of these other ones here are for more advanced stuff. So I'll kind of give you a before and after what AI can do to a program here. So here's the 2 pictures you were talking about. There's the picture you can see is daytime. I was outside of Cusco, Peru. There's trees out there. Here's the Milky Way shot. That's unprocessed. I just stacked them together, but I didn't do any enhancement there. But a lot of the trees were burned out. I didn't like the foreground, so I basically scanned the 2 together and ran it through that Neo program, and bingo, there you go. It was really easy to do. It didn't take a lot of processing skills. You know, if you know a little bit about image processing, anybody can do that. And I think it looks fairly natural. It seems like looks like there's moonlight out, kind of illuminating that. Got rid of the trees over there. But it does a very good job of smoothing it out. I used to have to do that by hand on Photoshop. No matter how hard I tried, I always felt like you could see the artificial line between the sky and the mountains, no matter how good you were and how many hours you put in. The AI programs make it look much more natural, okay? You've seen them with your phone. I think it's the Google Pixel phone. You know, they have that commercial where there's someone and then they have their ex-boyfriend or girlfriend there, and they eliminate it and they figure out what would have been behind the person when they eliminate it, and it looks perfectly normal. So it's crazy what those AI programs can do. This one, this is crazy. This took my photography skills to the limit back in 2002. I was using the best telescope you can get for the money, the best camera. I went out to Pawnee grasslands in the winter to photograph this very faint nebula called the Flaming Star Nebula. It's in Auriga, so it's a winter constellation. And it took my skills to the limit. The long exposure, out all night, and you can barely see the nebula, okay? Last year, this time, I buy a small little refractor. I set it up in my driveway, put in a light pollution filter, short exposure. I just wanted to see, is the telescope any good? Take this picture here and run it through an AI program, and it blows away that. I was like shocked. It made the stars pinpoint all the way to the edges there. There's lots of more detail, and this wasn't meant to be a really good photo. It was just a test to see if the telescope works. And it blows away my best effort in early 2000s with state-of-the-art equipment. So AI is just revolutionizing astronomy here. This is an advertisement for Blur Exterminator for what it can do here. So it can take a blurry image like that, it has algorithms to know what's a star, what's a nebula, how to clean it up, and you end up with the Orion Nebula looking something like that. So I put it to the test here. This is a very cold night in February. I was out in Pawnee Grasslands. I wanted to get the Cone Nebula. And you know what happens to metal when it gets cold, right? It contracts. So as the night went on, my telescope literally shrunk due to the very cold temperatures, which meant I was too cold to get out of my truck and refocus it. I don't have all the automated equipment to focus it. So by the end of the night, the stars are all blobby. Okay, and I was kind of like, oh man, I drove all the way out there, froze my tail off to get this picture that's kind of out of focus. I ran it through Blur Exterminator, and look at that. The stars are back to pinpoint focus. This detail starts to show up. Just amazing. And I did a wider field of view there. So a picture that I thought was ruined was saved by Blur Exterminator, an AI program that scans every star in and says, what should a star look like, and then turns them into pinpoints. Some people say it's cheating. I don't know. I think they call it progress. So that's one of the things it can do there. I think this is where it's heading someday. It's going to turn your $100 Walmart telescope into a $10,000 Takahashi. So now that's just extreme. I'm just doing a joke there. But anyway, this is kind of like the goal, what it's heading for. Take a blurry, old, kind of not so good image, run it through an AI program, and out pops something like that. Okay, that could be down the road. But that's kind of the gist of what AI is doing. One more slide here, and I think it's just about done. Some people process images. What you'll find out with image processing, here's the Veil Nebula. When you process the image, the stars get all blown out a lot of times, unless you really know what you're doing. So it's almost to the point where the stars are distracting. So you can run it through this AI program. It knows what a star is, totally eliminates the star, and then you can enhance your image there and put the stars back in, and the stars will be pinpoint. So a lot of stuff going on with AI and astrophotography, but it takes time to learn, just like anything. So, you know, someday down the road I'll get more into that. I have a lot of old images that I know have potential. I just have to reprocess them in with some of the AI programs and then see what I can get out of them. But it's a cool hobby. I mean, you jump in, be careful, it's addictive, okay, but there's a lot of cool stuff you can do. I've been doing it for many, many years. So with that said, I'll open it up to some questions you may have. Yeah.
Yeah, if you go out in the field often, you always have to reset up your equipment. What's the trick to getting your mount along?
Polar alignment, oh, that's tedious. There are things that make it faster. I do it old school. I've got a polar alignment scope, so it gets me really close, and I'll do what's called the drift method, where I'll go in right ascension and declination, track a star on high magnification till it doesn't drift anymore. And as long as you're not going too wide of a field, a few minutes of that usually works. If you're going really wide field, then you got to really polar align it with that drift method for a longer period of time, otherwise you get star rotation. So I do it old school, but I know there's some programs now where it'll look at a few things. I think Mark was telling me that, and it'll tell you how close you are to alignment, and then you tweak your mount that way. That's one of the tedious things I don't like doing, you know, because you're just setting up, you want to start taking pictures and spend a half an hour polar aligning. So yeah, it's just one of those things. I leave that out because that'll discourage people from trying this. So.
Scott, you got something about that?
Oh, yes.
Can you talk for a quick second about your workflow in post, like stitching and stacking?
Okay, so first thing I'll do is I'll stack the images together, and there's different programs that do that. PixInsight, there's a couple others that are off the top of my head I can't remember. So first thing I'll do is I'll stack them together. And I used to do everything in Photoshop, but I'm slowly going more towards PixInsight. But in Photoshop, I'll do all the stretching in there. And then I'll clean up the image. In the stacking process, there's AI programs in there that'll pick out all the satellites and eliminate them. So I used to have to go through there, and there's so many satellites out there, and you're kind of eliminating them by hand on the computer, and your hand gets tired by crossing them out with the mouse. So now with stacking them, it'll eliminate them all there. And then I try not to enhance too much. You know, I try to keep a natural color. So I'll stretch the images, and then I'll use some of the histograms there to, what's the hue and saturation a little bit in Photoshop, just to make it punch a little bit. And then I'll use the AI programs, the two I showed you, with the Blur Exterminator to tighten up the stars, and then the other one to smooth the background out. So not a whole lot, but that's kind of the general workflow. Okay, sure. Any other questions? Yeah.
So if you use AI to smooth out the background, do you no longer have to take dark frames and things like that?
Yeah, you know, I've been hearing with the newer CCD cameras that it's not as necessary. I do my dark frame on site. So I do that one extra picture and then my S-Big camera adds it in automatically. So I don't mess with the dark frames, and I know it would probably make it a little bit better to take a whole bunch of dark frames and flats and bias frames. I've done it a few times. I'm like, you know what? That's a lot of work and the difference isn't that great. So I know some people get all caught up on the dark frames. So dark frames is just basically you close your shutter lens and you take some pictures at that temperature. So all of the electronic noise of your camera basically gets eliminated with the bright image. So it smooths it out a little bit, but it's a lot of work for a little bit of gain in camera things. So, yeah. Yes.
When you stack the images, how do you line up the stars that are in the individual?
So the programs do it automatically. So if you buy any kind of star stacker program, what it'll do is it'll scan them through. The old-fashioned way in Photoshop, you had to pick 4 stars and then do like an overlay and change your transparency so you could see through it and then move it. I even started before that. The old room, the dark room thing, you used to take it in the dark room and stack your negatives on top of one another. That was really tedious with a magnifier, okay? But now the stacking programs do it automatically for you. You don't even have to.
What's the program you use?
So the main one I use there is called PixInsight, but that's kind of an expensive one. There's some free download ones I'd recommend. If you just Google star stacker programs, I forget the name of the free download one, but I've tried it before and they work fine. It'll pick out the stars for you and stack them together automatically. Do you remember what it is, John?
I don't. I know that some of those you can actually run video, and it'll pick out all the clear video frames and
Stack them all together to do a continuous video frame?
Just got everything working.
Okay, cool. Yeah,
Deep Sky Stacker is.
that's the one I was thinking of, Deep Sky Stacker. I've used that. Yeah, and it's a free program and it worked fine, so yeah. Yeah.
So are there any specific types of cameras that would be really good for taking pictures of Milky Way?
Yeah, they asked me that in night astronomy. When digital cameras first came out, Canon was leading the way with astrophotography type of cameras. They had the best sensitivity and all that stuff. Since then, all of the cameras are fairly equal now. So it's whatever camera lens you have an affinity to and you like using, you're gonna be just fine with. Most astronomers, astrophotographers kind of stick with Canon because that's what they started off with and they have the lenses for them. But I've seen great results from Nikon, Sony, you name it, they're all out there. You know, any decent camera will work. If this were 20 years ago, I would say Canon is the way to go. Today, you can anyone would work.
Just make sure you're adjusting your lens to get the field.
Yeah, I should have talked about that. If you're taking pictures with astrophotography, set the lens to focus to infinity. And make sure it's not on an autofocus, because if you do autofocus, it'll keep going back and forth trying to find out, what am I focusing on? It's all dark out here, you know? So just go to infinity. And I always recommend a wide angle lens if you can choose between the two as you're learning this stuff, because it's more forgiving.
What the wide angle is versus the telephoto.
Yeah, so like a 35 millimeter lens or a 25 millimeter lens is going to give you a wider field of view, and it's easier to take pictures with. As you get more and more towards a telephoto lens, then any little bump of the tripod and the stars all look shaky and vibrating. So yeah, so it's pretty easy to do. Just those are the main things. Bless you. Any other questions, John?
I was going to jump in that Canon for a while had like a 60DA, and they took out the infrared filter.
Yeah, it was made just for astrophotography. Mm-hmm. Yeah. Okay. Yeah. So, sure. It's just dedicated for that.
The downfall to that, though, is it ruins the natural color of your daytime color.
Yeah. Everything has a red cast to it. Cool. Well, it's a beautiful night out there. I want you guys to get a chance to look through the telescope and do some observing. So, yeah.
So like on that camera there, could you put a solar filter on it and take a photo of the sun?
Yeah, you could, but actually, yeah, what I did is just took the solar filter from my telescope and I put it over the camera and got some pictures of the eclipses. Now, in astrophotography, there's fields to specialize in: planetary photography, lunar, solar, and there's people that take solar images with a special solar scope that blow me away. But like I said, you don't want to be a jack of all trades because then you're not going to be really good at anything. But people that do solar photography, they can get a special dedicated telescope with a hydrogen filter just for that. And then you could put the telescope or the camera in the back of the telescope. And I've seen some amazing pictures you would think was taken by NASA that are done here, earthbound. So, but yeah, any kind of filter on top of that without a filter is just going to blur out. I changed the exposure and I did get some images. Who was it that took that eclipse over there? Can you read? Yeah. Can you hold that picture up? That was a really cool picture. The solar eclipse that we just had last week. So, do you want to talk about how you did that?
Not a whole lot to talk about. Sony camera, an old 400 millimeter manual focus lens, and I don't even want to tell you about the solar filter that I use because you really shouldn't do it that way.
Was it a welding hood?
No. It is 3 layers of space blankets that you can get from Walmart.
Nice.
Don't look through it.
No.
With your eyes, it works for the camera.
You can buy a threaded.
Yeah.
You can buy a threaded solar filter.
Yeah, you can buy a threaded filter that goes on your lens.
For under $100.
Yeah, for under $100.
There you go. All right. Well, no more questions. I'll end it with that. So, thank you for coming out. I really appreciate it.